For this example, we are going to take a look at a logarithmic equation. We will identify and sketch the parent function and then sketch the given equation. So we're going to be using transformations to do the sketching. Our function that we're going to graph is f of x is equal to log base 3 of x minus 4. To identify the parent function, that's the first thing we want to do. That's always pretty easy. You just need y is equal to your log. You want to keep the base of the log the same, and then put your variable x after that. So the parent function is going to be y is equal to log base 3 of x for this particular function. From there, you should be able to come up with a couple of characteristics from the graph. In the video where we introduced graphing logarithmic functions, we said that all parent function log graphs have an x-intercept at 1, so they go through the point 1, 0. Another point they go through is the base comma 1, and the base in this particular problem is 3. And then they also have a vertical asymptote right on the y-axis. The equation for that would be x is equal to 0. So if I graph this equation, here is what we would end up with. I'm going to graph the point 1, 0. I'm going to graph the point 3, 1. I'm going to put in a vertical asymptote at x is equal to 0, which is right on top of our y-axis. And then I can draw in a logarithmic shape from there. The graph will start next to the vertical asymptote at the bottom of the graph, just a little to the right of that. It will curve and go through those 2 points and look something like that. This graph will continue to go to the right and up, to the right and up. It starts out pretty steep, but gets less steep as you go to the right, but it's never going to level out. It's going to continue going to the right and up. So that is the parent function equation, and this is what the graph of that would look like. The second part of the directions are to sketch the given function, so now we want to sketch log base 3 of x minus 4. Anytime you have a function and you have some addition or subtraction in that function, that will result in a translation in your parent function graph. This minus 4 that's on the end is either going to take our parent function graph and slide it up or down or left or right. If your addition or subtraction is inside of grouping symbols, that would move the graph either to the left or to the right. If it's not, it would move the graph either up or down. This x with the minus 4 afterward, the x minus 4 is not in grouping symbols, so this is vertical shift. It'll either move the graph upward or downward, and plus is up and minus is down for vertical shift. So when I compare these two equations, the only thing that's different is the subtract 4, and I know that that will take this parent function graph and it will slide it down 4 units because the x minus 4 is not in parentheses, it's not in grouping symbols. So I'm going to take the parent function that I have here, and to make a very quick sketch, I'm going to take the 2 points in the vertical asymptote, I'm going to slide that down 4 units, and then that will be the graph of f of x is equal to log base 3 of x minus 4. So let me start with the points. You can either do the points or the asymptote first, it doesn't matter, but we'll take those three features and slide them all down 4 units. So first, let me take this point here, which is at the point 1, 0, and I'm going to move that down 4 units. So from the point 1, 0, moving down 4, the graph of this function will go through this point, which does happen to be the point 1, negative 4. The parent function also goes through 3, 1, and I need to move that point down 4 units also. So 3, 1 is where the parent function's point would be, and I need to move that down 4 units. And that would be the point 3, negative 3. I also need to take this vertical asymptote and slide that down 3 units. But if you take a vertical line and you just slide it downward, it does not change its location at all, really. At least it doesn't look like it. Technically, it has moved down 4 units, but it doesn't appear to have moved at all because it is a vertical line. And then from there, we would want to draw in that shape. So there is function f. For letter B, I'm going to take a look at f of x is equal to log base 5 of x minus 2. The parent function would be y is equal to, keep the base of the log the same. And I know that all parent functions go through the point 1, 0, go through the point base, 1, so for this problem it would be 5, 1, and have a vertical asymptote right on our y-axis. So coming up with the graph of our parent function, 1, 0, 5, 1, vertical asymptote right on our y-axis, and then our shape for our log graph. So there's the parent function equation and its graph. Last part of the directions, we need to use that graph to graph f of x is equal to log base 5 of x minus 2. The x minus 2 that's here, any addition or subtraction is going to be a translation in our graph and move the graph up or down or left or right. Here the subtraction is in grouping symbols, so this is horizontal shift. That will slide our graph either to the right or to the left. Vertical shift, the directions kind of make sense. Plus is up, minus is down, but for horizontal it is backwards. So if you're thinking of shifting in a negative direction, we usually would think of that as moving to the left. But this x minus 2 actually does move the graph over to the right 2 units. So if I take this green graph of our parent function and move it over to the right 2 units, I will have a reasonable sketch for our original function. So I'm going to take these 3 features in my graph, the 2 points in the asymptote, and I'm going to move all of them right 2 units. So first, let me start with this point at 1, 0. If I start with our x-intercept here at 1, 0, and I go over to the right 2, that means that the point 3, 0 is going to be one of the points on the graph of function f. 5, 1 is one of the points on our parent function graph. I need to move that over to the right 2 units. So 7, 1 is also going to be a point on our graph for function f. And then we have a vertical line right on the y-axis. And I need to move that also over to the right 2. So now I have the asymptote and the 2 points graphed accurately. And now I can just draw in from there a logarithmic shaped graph. And that is our graph for the original function f. For letter C, let's take a look at f of x is equal to log base 6 of x plus 3 plus 1. So the parent function would be y is equal to log base 6 of x. We would have a point at 1, 0. We would have a point at the base, comma 1, so that would be 6, 1, and we would have a vertical asymptote with the equation x is equal to 0. So the parent function's graph would look like this. Point at 1, 0. Point at base, comma 1. For this problem, that would be 6, comma 1. We have our vertical asymptote here. And the shape of these log graphs looks like that. Again, this graph is going to continue going to the right and upward, so you don't want it to level out. It should be gradually increasing. Looking at the addition or subtraction in this problem, that will tell us how we have to shift the parent function. We have addition in two places. Inside the grouping symbols, we have x plus 3, that's horizontal shift. That's going to move our graph to the left 3 units, and the plus 1 in the end is up 1. So I need to take our parent function graph and move those 2 points and the asymptote left 3 and up 1. So first, let me take the point 1, 0. That would be here. I'm going to go left 3 and up 1. So that would be the point negative 2, 1. Need to take the point 6, 1. And I need to go left 3 and then up 1. So that would be the point 3, 3. We have a vertical asymptote on our parent function right on top of the y-axis. I need to move it left 3 and then up 1, but the up 1 really doesn't change the look of the graph, that vertical asymptote at all, just the shift over to the left 3. We're technically going left 3 and up 1, but visually we only see the difference of the horizontal shift. Then from there we draw in our shape. And that is a reasonable sketch for the original function. It is the parent function for log base 6, and we move it left 3 and up 1.